All right, let's jump right in. For a while now, we've thought of AI as this thing that predicts the next word or, creates an image when we ask it to. But we're standing at a really exciting turning point. We're moving away from that passive AI and into a whole new world of software that can actually solve problems on its own. And we're talking, of course, about AI agents.
And this quote, it absolutely nails it. We're going beyond just the language model, the brain in a jar, so to speak, and we're building complete, actually useful applications around them. We're talking about systems that don't just give you an answer, they actively go out and get things done for you.
Okay, so let's get into it. To really understand how these things work, we first have to break down what an agent is. Because let's be honest, it's way more than just a chatbot with a fancier name.
At its heart, an AI agent is a full system, and system is the key word here, that is designed to achieve a goal. Sure, it uses a language model as its engine, but the magic is that it's constantly looping. It's thinking, then it's acting, then it's observing what happened over and over until its job is done. And this whole system is really built on three essential parts.
So what are these three parts? You've got the model, the tools, and the orchestration. And what's really cool is how perfectly this maps to a simple analogy we can all understand. The model, that's the brain, right? It's the part that does all the thinking and reasoning. The tools are the hands. They let the agent actually interact with the digital world through things like APIs. And finally, you have the orchestration, which is like the nervous system, connecting the brain to the hands and managing the whole show.
Okay, so we've got the brain, the hands, and the nervous system. How do they actually work together to solve a real problem? Well, it's not a one-and-done kind of thing. It's a continuous cycle.
It really all comes down to this fundamental 5-step process. You can just think of it as a think, act, observe loop. First, it gets a mission from you. Then it scans all the available information. Next, it thinks up a plan. Then it takes the first action using one of its tools. And finally, this is the crucial part, it observes the result and loops right back to the thinking step, repeating this cycle until the job is done.
And this is a perfect real-world example of that loop in action. A customer asks about their order. Notice the agent doesn't just guess. It immediately creates a little plan for itself. Step 1, find the order. Step 2, track the shipment. Step 3, tell the customer what's up. It follows that plan methodically, step by step. But, and this is a big but, this whole idea of observing a result and then using that information for the next step, well, it relies on one critical thing that language models just don't have naturally, and that's memory. And this right here is the fundamental problem that every developer in this space has to solve. If your model is basically a goldfish with a 3-second memory, how can it possibly follow a multi-step plan? Without a solution for memory, an agent is just, well, not very smart.
So here's the thing you have to wrap your head around. A language model is stateless. Its entire universe, everything it knows, is confined to this tiny little thing called a context window inside a single API call. And the moment that call is over, poof, it's all gone. It has total amnesia. Every single time you interact with it, it's like meeting you for the very first time.
So how on earth do you fix this amnesia problem? Well, the solution has led to this whole new discipline, this new art form really, called context engineering. It's all about manually building the agent's memory for every single turn of the conversation.
I absolutely love this analogy because it's so perfect. Think of a master chef. Before they even think about turning on the stove, they do their mise en place. They get all their vegetables chopped, their spices measured, everything laid out perfectly. That is exactly what context engineering does for the AI. It prepares all the ingredients, the history, the user info, the tool results, and arranges them just right so the model has everything it needs to cook up a brilliant response.
And this whole preparation process is managed by two really key ideas. First, you have sessions. Think of a session like your workbench while you're in the middle of a project. It's kind of messy, it's got all your tools out, all the immediate stuff you need right now. Then you have memory. And memory is like your perfectly organized filing cabinet. When the project is done, you don't just shove the entire messy workbench into storage, right? No, you take only the most important, finalized pieces of information and you file them away neatly for the long term.
And it's super important here to not get memory confused with another technology you've probably heard a lot about, RAG, or Retrieval Augmented Generation. Here's the simplest way to think about the difference. RAG is the agent's research librarian. It goes to a library of documents, your PDFs, your wikis, and pulls out facts. Memory, on the other hand, is the agent's personal assistant. It remembers its interactions with you. So, RAG makes the agent an expert on the world. Memory makes the agent an expert on you.
So what's the big deal? Why does mastering all this stuff, the loop, the context, the memory, why does it matter so much? Well, because once you crack that memory problem, you unlock a clear roadmap for building AI that is just fundamentally more powerful and capable.
Once you have memory, you can start climbing this ladder of agent capabilities. You start at level 1 with a simple agent that can use a tool to check the weather. Cool. But then you get to level 2, where you can create complex, multi-step plans. Then it gets really wild. At level 3, you can build entire teams of specialized agents that delegate tasks to each other. And at the very frontier, level 4, you have systems that can actually recognize their own shortcomings and then build new tools or even whole new agents to fill in those gaps themselves.
This whole evolution, from a simple tool into a strategic, collaborative, and even self-improving system, this isn't science fiction. It's happening right now. And it really forces us to ask a much bigger question. As these systems get more and more capable, how is our relationship with them going to change? That shift from a passive tool to a true collaborator, well, it's really just getting started.